Hello and welcome to SudoKanard. I usually don't really care for Halloween, but on this special Halloween, I'm seeing this puzzle, which was published on Logic Masters Deutschland by Olima. It's called Zackman and Goblin, and there's a very striking visual theme with a Pac-Man and this ghost, and all those. Don't know how this is called. All those pellets, I think. Yes, all those pellets that Pac-Man is supposed to eat, I guess. And then you see there are colored lines, and they follow the recent convention that purple lines are Renban lines, which means that those purple cells contain different digits which form a consecutive set, and you can see that there are 8 of them, so they must be digits from 1 to 8 or from 2 to 9. And in both cases, we will have digits from 2 to 8 on this purple line. Here we have 3 consecutive digits in any order. And the green ones are German whispers, which means that whenever you have 2 digits separated by a green line, they must have a difference of at least 5. Then we have crop key pairs, which means that separated by a black dot, those digits must be in a ratio of 2 to 1. And here we have pairs of consecutive digits. And this could be mistaken for a Renban line, but it isn't, because digits are allowed to repeat on the shape that I just highlighted. So I put the link in the description to this puzzle. I haven't solved it yet, so I'm not quite sure about the difficulty, but let's try. So let's start with this ghost. We know that the digits here separated by green line have a difference of at least 5, so 5 can never be on a green cell, and 5 can't be on with a black dot, because 5 would be with 2.5 or with 10, which does not appear in this puzzle. So in this region, 5 can only be in this corner. Now let's use some coloring, because along a German whisper we have high digits and low digits in alternate positions. So let's say I'm using orange for one of the classes and blue for the other one. Here those digits alternate between big and small, and I have to determine how. What did I do? I have to determine whether orange is small or big. And something else is that, so we see that in this region we have 4 orange cells, so those must be on the same side. All 4 of them must be big, or all 4 of them must be small. And the interesting part, I think this must be a 4 or a 6. So why am I saying that? Because let's imagine those 4 orange cells are small, then one of them must be 4, and 4 can only be next to a 9 on a German whisper. So 4 here would put a 9 here and a 9 there, that wouldn't work. And the same happens here. 4 here would put a 9 here and a 9 there. And 4 here would put a 9 here and there. So 4 could only be here, and the same happens by symmetry with 6. So this is 4 or 6. And this is now 1 or 9, according to what comes here. And then, not sure about that. But I'm thinking big digits would be more restrictive. So let's try with big digits to begin with. So if that's a 6, then that's a 1. And this has to be a big digit, but because of this crop keeper, it can only be 8. 7 or 9 wouldn't work. We wouldn't put 18, for example, into this cell. So this is now 7 or 9. This is 7 or 9. Because of the crop key, this is 3, this is 4. And here we must have 1 and 2. And they both work. So that's a valid option. I'm tempted to say this can only be 2 or 3 because of this. And I see absolutely no issue with this theory. So let's try with 4. Is there an issue with 4? If I'm putting this, then this must be from 1 to 3. So this should be 2 or 8. Those also must be from 1 to 3. And note that 3 on the... So we know there's a 3 somewhere. And 3 must be surrounded by 8 and 9. So if 3 is here, then we have 8 and 9 here, and that's a 2. If 3 is here, then that's a 6. That's 8. And that's 8 as well. And we must have 7 and 9 in here and in there. And we see that it's working. So there are actually lots of options for this part. So I think I just move on to something else. Perhaps. I'm just saying this. So that's interesting because I know that with 3 digits in such a succession, they must be from 1 to 4 in some order, or 2, 4, and 8 in some order. So there's always a 2 and a 4 in here. And I must take this into account because here this 4 would, if this is a 4, then this can't be a 2. It will always be an 8. And if that's a 3, 6, then that has to be a 3. Oh, and that does the trick. If that's a 4, no, sorry, I said a 2, but that's an 8. In case this is a 4, then that's an 8. This is how it works. And there's something interesting in here. I was saying if this is 6, then this has to be 8 and this has to be 4, but this is prevented by that. This is what I missed a few minutes ago. So this case can't happen. So here we have a 4, that's an 8. Now this is from 1 to 3 and this as well, but a 1 here would put a 2 there, which would clash. Oh, and this 8 says even that we have here 1, 2, and 4 in this order. So now this can't be a power of 2. This has to be a 6 with a 3. That's a 1. So sorry, that's a 9. That's an 8 because of this 3. And we get 7 and 9 in those two cells. And that's a small digit. That's not from 1, 2, and 4, so that's a 3. This can't be 7, the difference would be too small, and that's a 7. And we're left with 5 and 9 on this row. And that's a big digit. It could be 8 or 9. And this is smaller, from 1 to 4, but because of this, we have consecutive digits in here, so 1 is too far away, and 4 would be repeated, so that doesn't work, and this must be a 3. Here we have the 2 again, and the 1 or 4, which is the same digit as this one. This now is none of those digits. It could still be 3, 6, or 8. 3 or 6 would be accompanied by the counterpart, and 8 would be accompanied by a 4. So we know for a fact that none of those 5 digits in here are from those two. But we know that those 2 digits must appear somewhere on the Renban line. So those 2 digits must be somewhere in here, which is not so useful. Something else that seems interesting is this whisper. Those are consecutive digits. Well, they are on the same side of 5. And here we have a digit on the other side, and it can't be 1, 2, 4. If this is small, then this has to be a 3, so that we have 4, 8, and 1. And here we must have 9 and 8. And this breaks because 1 and 9 cannot be both on this Renban line, because a Renban with 1 and 9 must include all 9 digits, but this one has only 8 digits, so that's not possible. So I was wondering whether this could be a 3, and it can't, so it has to be a big digit. And those must be small digits, but they can't be 2 and they can't be 1, because 1 would be with the 2, so they must be 3 and 4. And this is not necessarily a 9. I am really enjoying this puzzle. So now we know that 3 and 4 are here on the Renban, so this can never be a 4 as the 1, because the digits are not allowed to repeat on the Renban line. And something interesting now is that 3 and 4 don't appear anywhere else on the Renban line, so they must be somewhere in here. Obviously this digit won't be here, so it will appear in one of those two. I'm seeing something else. 4 is not here, but it must appear on row 4. It won't appear on this Renban line, so 4 is here, and we now know that this is a 3-6 pair. So that's a 4 and that's a 3. Good. So this row still needs 5, 7, and 6. And 6 is not here, so 6 is there. And that's interesting, considering that here we have consecutive digits. And as you know, consecutive digits have alternating parity. And we see that only 8 is available as an even digit. So, and there must be at least 1 even digit. We won't have 2 even digits on the end of this sequence, so 8 has to be here, surrounded by 7 and 9, so that's 7 here and 9 there. 7 is not here, 7 is there, and that's a 1. 8 here goes there. Here we need 2 and 5. And on this Renban line, we now know that the digits are 1 through 8. So we are missing 2, 5, and 6. There's 2 or 5 here. 2, 5, 6. Because of this 2, that's not a 2. And this digit must be different from both of them. They must be different here by Sudoku, and they must be different here by the rules of Renban. So that has to be a 6, that's the 5, that's the 2, 5, and by Sudoku I get this 3 and this 6. And this 5 resolves the 5-9 pair up there. That's really, really nice. So now those are consecutive. That's not a 6, so that's 8. And I get the 9 up there. That must be 7 or 9, but there's a 9 in the column. That can't be an 8, so that's a 6. That can't be a 7, so that's a 5. Here we have 2 consecutive digits, different from all of those. So they must be from 1, 2, 3, 4. And they can't be 1 and 2, so they must be from 2, 3, and 4. And there's a 3 in there. So the rest is just classic Sudoku. This column is 1, 2, and 5. 5 can only be here. That's the one that's a 2. And there's no 2 in here. 9 is not here, so it's here. That's not 8, that's 1 and 8. This one resolves the 1, 2 pair there. Here we need 2 and 6. That's a 7, that's a 4. 4 are not here, not interesting. This column needs a 5, it can only be here. It also needs 6 and 7, so that's 7. No, sorry. That's typical Kanard mistake. 4 and 5, so that's 4. I said 4 and 5, that's 4 and 6. Oops. So the argument for 4 works, although it was not quite the right thing to say. I need a 2 here, it can only be there. I need 9 and 3, so that's 9, and that's 3. Here I need 1, 3, 6, and 7, so that's 1 and 7, and 3 and 6 there. Here I need 2, 8, and 9, so that's 9, that's 2, that's 8. Here I need 1, 4, and 7, so that's 7, that's 1, and that's 4. Up there, that's a 3. Here I need 1 and 8, so that's 1, that's 8. Here I need 6 and 7, 4 and 8. And here we're left with 5 and 7. 6 and 5, and 3 and 6, and that's it. So that was a really nice puzzle. The beginning was a bit on the tricky side, but I had overlooked this fact that 2 and 4 had to be somewhere in here. After that, it has a really, really nice flow. So easy to medium difficulty puzzle, and quite fun one with a magnificent visual theme. Thanks for watching this video. Happy Halloween if this is something that you do. And see you soon on SudoKanard.